Hey guys, and welcome back. Let's go ahead and jump into some practical examples of how these different exposures of services work on a Kubernetes cluster here. So the first thing that we're going to want to do is to actually create a cluster, and I'm going to be using Amazon Web Services, but if you want to use another cloud vendor, feel free to follow along. So what I'm going to do for starters is to just fire up a browser here. And there is a great utility that you can use if you are using Amazon Web Services called EKSCTL. This is just a really nice command line utility that will easily allow you to spin up a EKS cluster. And so you can just run this simple command to spin up a cluster. So go ahead and get this utility installed on your system and make sure that you've got your AWS credentials configured so that you have access to deploy an EKS cluster into your environment. So I've got EKSCTL already installed on my system here. So I'm just going to run EKSCTL here really quick, and we'll just run a create cluster command. So we'll do create cluster, and then I would generally recommend using the spot parameter if you're using, if you want to save money on your hourly cost for your nodes that are joined to your cluster. It's just a less expensive way to obtain compute capacity. And then I need to specify my credentials profile name. I have a credentials profile called CBT in my AWS credentials file. So I'll go ahead and just use that. And then if you were to hit enter, that would just go ahead and deploy the cluster. It does take about maybe 30 to 45 minutes to deploy. So I've actually already provisioned one. So if I do EKSCTL list cluster, or I think it's get cluster actually, we should be able to see my list of clusters. Of course, I need to plug in my credentials profile here. And you can see I've got a cluster here called floral painting. So that's the cluster that I'm going to be using in the remainder of this skill. So let's go ahead and run kubectl version just to make sure that we are able to connect to our environment here. And it looks like that is up and running just fine because I've got my server version right here. And so now what we want to do is maybe spin up a couple of pods. So if I run kubectl, let's say create a namespace to work inside of for now. I'll call this networking. And then I'm going to go ahead and just do kubens and change into the kube networking namespace. And that way, any pods that I create or any service controllers that I create will go into that namespace. And you can always run kubectl get ns as well to list all of the namespaces on your cluster here. Of course, the only one that I've personally defined here is this networking namespace that I just created. So let's go ahead and spin up a pod running just a simple Nginx web server for starters. We'll do kubectl, and then we'll do run. And we'll say image equals Nginx. And of course, we want to make sure that it's exposed on port 80. We'll do port 80. And we need to give it a name. So let's do Nginx 1. And let's see if that works. All right, so we've spun up a new pod here with Nginx. And we'll just kind of monitor it to make sure it goes up and running successfully. So we'll do kubectl describe pod Nginx 1. And in a moment here, you should see in the logs that it starts up after it downloads the container image from the Docker Hub. I think my cluster already had that cached. So now we've got our Nginx service exposed on port 80 here. And if we take a look at the output from the describe command, you can see the pod does actually have an IP address that's on my Amazon VPC software-defined network in the cloud. And the way that the pod was able to get an IP address on the VPC directly rather than getting a cluster IP is because it uses the Amazon VPC Container Network Interface, or CNI, and that is what allows the Kubernetes cluster to allocate an IP address from the VPC directly to the pod. So now what we can do is to spin up a service controller that points to this particular pod. Now, at the moment, I don't really have any custom labels assigned to that pod that I could use as selectors. It automatically assigned this run label here. but I'm just going to go ahead and set a label on that pod so that when we create a service, we have a label that we can point to. Let me run kubectl set, and then we are going to set a label. Actually, I want the label command. So kubectl label, and I'm going to label the pod named nginx1, and we need to give it a label that we want to apply. Let's take a look at the help for this just to better understand the syntax here. And so what we can do is just provide a label name and value. So we'll go ahead and give it a name like name equals my app. And so any pods that have the label of name set to my app are going to be used to target from our service controller. Let's go ahead and spin up a second pod as well, just so that we have two different pods to load balance our traffic across. So I'm going to just hit up arrow a few times, and then we'll create another pod called nginx2 using the same container image, and we'll also expose it on port 80. So let's do kubectl describe on nginx2. And so now we should have two different pods running. Whoops, let me do pod/nginx2 there. And so that should have its own separate IP address, sure enough, exposed on port 80, and it's up and running. So let's actually create the service now. And I'm going to use the kubectl command line utility to create that. So let's search for kubectl docs. And there is a really good reference document out here that talks about all of the different kubectl commands. And in this case, what we're going to want to do is to create a service using a NodePort. So if we take a look at the create subcommand here and then go down to service NodePort, this shows you the syntax to create a NodePort-based service. So you don't actually do kubectl create service, you actually just do kubectl create NodePort, and that will actually create a service resource of the type NodePort. And then the options that we have here are to create a port mapping. So we'll specify a port on the hosts that we want to expose, and then the target port is going to be the port of the application that's actually running inside of our pods, which of course in this case is going to be TCP port 80, because that's what Nginx is listening on. So let's try to do a kubectl create NodePort, and then of course we need to give the service itself a name as well. So I'm going to head back over to my terminal here. We'll do kubectl create NodePort, and then we'll give it a name. Let's call it my Nginx app. And then I need to give it a TCP port mapping. So I'll do --TCP equals, and then we'll pick a random port on the outside. Let's say 35,321. And then we'll do a colon and plug in port 80, because that's where Nginx is listening on for both of our pods. Now we also need to make sure that we are able to select those pods using a selector, and we'll do that in a second step. So let's go ahead and just hit enter to run this command, and it looks like it doesn't like it for some reason. So let's take a look at the options here and see what's going on. So I'm going to switch over to the terminal here and just tack on --help. So let me just do create NodePort --help. And then let's take a look at the options that we have here. And I don't see TCP, so that might be an old version of the documentation. So it looks like the Kubernetes documentation for kubectl is actually a bit outdated, because when I run kubectl create in my current version of the kubectl command line utility, you can actually see that we don't have NodePort here. So they must have changed the utility to actually use create service instead. So the create NodePort must be for an older version of the kubectl command line utility. So let's do kubectl create service. And then it looks like we have NodePort as a child context of service, which actually makes a lot of sense, because when you create a service, you have these different options like cluster IP, load balancer, and NodePort. So let's do create service NodePort, and it's asking for a name, so let's call it my Nginx app, and then we'll do -- help. And there, sure enough, now we have the access to that TCP option. So let's go ahead and do TCP equals 35,321 and map that to port 80. All right, so now we've got the service itself created. So let's do a kubectl describe service my Nginx app and just see what that resource looks like on our cluster. And sure enough, you can see that it is up and running here, and it did get an IP address on the cluster network. If you remember from the diagram that we were looking at previously, that is going to be on this cluster network right up here, and that's only internal to the cluster. So the service controller itself does not get an IP address on the VPC directly. And what we're doing in this case is we're actually doing a NodePort exposure. So we're going to take a port on each of the worker nodes, and the service controller will route that traffic over to the pods. So it's kind of a little bit roundabout. If you have a client that's coming into one of these nodes, basically going to forward it over to the service controller on that internal cluster network, and then the service controller is actually going to forward the traffic over to one of the pods, and the pods, remember, do have network interfaces on the VPC directly. So it seems a little bit roundabout, but that's kind of how you can handle load balancing your pods in this manner with the service controller. Let's come back over to our terminal here, and as you can see, port 35,321 is being forwarded to port 80. So now what we need to do is actually update the selector on this. So we've created the service, but the default selector is actually just using the same name as the service controller itself. So what we need to do is actually change this selector here to point to the selector that we applied to our pods. And if you recall, we assigned a label called name equals my app to pod number 1, and I think we actually forgot to do that on pod number 2, so I'm just going to run that just to make sure that both of our pods have the correct label here. So what we need to do is edit our service controller to have name equals my app as the selector rather than having an app key equal my Nginx app. So what we can do to do that is do kubectl set, and then we can do set selector. Let's do set selector and take a look at the help for that. And what we're going to want to do is set the selector on the service. So we'll have to plug in the service name, but then we are going to basically plug in our key value pairs here afterward. And so that's how we're going to assign them to the service. We'll do set selector on service my Nginx app. And if we run that, it's going to, of course, ask us for the resource. Actually, we were already providing the resource here, so what we need to do is just go ahead and plug in the name equals, what was it, Nginx? Let's go find that again. Oh, name equals my app. So let's go ahead and plug that in. And now you can see we've added that selector. So let's do a describe on our service controller again. And now you can see that the selector has been updated to say name equals my app, which is the correct selector for our pods. So at this point, we should be able to hit the service controller and validate that it is load balancing our traffic to our pods. So you might think, okay, well, I want to hit this cluster IP from the service controller. However, there's a problem with that. We can't actually hit this internal cluster IP address because we are not running a pod on the inside of that cluster right now. So in order for us to actually test this out, what we need to do is spin up a host inside of the VPC that can sit side by side with the actual worker nodes here. And remember, the worker nodes themselves are going to be listening on that outside port, and then they're going to be responsible for forwarding the traffic over to the service controller's internal cluster IP address. So we have no way to route to this CIDR block from outside. So what I'm actually going to do is to head over to my browser and I'm going to deploy a virtual machine running Linux side by side with the devices that are in my cluster. So we'll do launch new instance here, and then find Ubuntu Linux, and we'll just choose a relatively small machine type here, and we'll choose Spot. And we want to make sure that we're deploying into the correct VPC that's going to be side by side with the worker nodes. I'm going to choose my floral painting here, and then I also need to make sure that I choose a public subnet for it so that we can remotely SSH into that virtual machine so we can test out our connectivity to our internal service. So let's choose a security group that has inbound access on port 22. So we can SSH into this VM, and then we'll go ahead and launch it. And then we'll get SSH'd into it so we can test out that connectivity. So let's find its IP address over here in the EC2 console. And it looks like it's this one right here. So we'll grab this IP address, and then we'll fire up a new tab in our terminal. We'll do SSH Ubuntu, and we'll hop onto that IP. And then at this point, what we're going to do from this machine is install a utility called http-ie. So I'm going to do sudo apt update and sudo apt install http-ie --yes. And this is just a handy utility to be able to test out HTTP connectivity to different services. So what we're going to do is use this utility to actually ping the service on one of the worker nodes that's in our cluster here. So the first thing we need to do is actually find out which nodes are worker nodes, and then we need to find the IP address of those worker nodes and pick one, and then hit our service controller on port 35321, which is what we exposed the service on. So I'm going to head over to the management console here again. And as you can see, I've got two worker nodes here that are joined to this floral painting cluster. And I'm going to find the private IP address for one of those nodes. And it looks like they actually have two different IPs assigned each here. And so I'm just going to grab one of those private IPv4 addresses of those nodes, and then we'll run HTTP, and we'll hit that IP address, and we want to hit it on port 35321, which I believe is the port we exposed it on. Sure enough, 35321. So let's go ahead and run that command, and it should connect, although it looks like we're having some failures here. And that's most likely due to the security groups that are associated with my cluster nodes. So what I need to do is find the cluster nodes, go to the security group for the cluster nodes, and I need to make sure that I'm allowing inbound access from this particular node that I just spun up to test from. So I've actually got a rule here that is allowing inbound access from anywhere. I'm not quite sure why that's not working at the moment. So let's see what's going on here. And I can actually see here that even though we chose port 35321, it looks like the actual node port that was assigned down here is actually 31605. So let's go ahead and try that port instead. So we'll do 31605. And as you can see, sure enough, that is giving us our traffic here. So if we were to just hit up arrow and continue to run this command, we're basically going to be hitting both of the pods inside of our environment. So I could actually come over here and destroy one of those pods. Let's do like kubectl delete pod nginx1, and that'll just tear down one of those pods that we just created. And now if I come back over to this test virtual machine, you can see that the service controller is still successfully routing traffic to the second pod that's running the web application. So that's how we can route traffic using a NodePort to multiple pods with a service controller. I hope this has been informative for you, and I'd like to thank you for viewing.